All right, we're good. All right, so again, I'll restart. Good afternoon. My name is Hasan Siraj. Again, I hope you are having a great time in this beautiful city of Prague. I'm going to talk to you about a mission that we have at Broadcom, which is democratizing networking. Basically connecting everything and everyone on the planet based on open protocols and open standards with relentless focus on performance and scale while minimizing power and cost for networking systems. Now, I will take you back. It's been a long journey, and I'll take you back to 2010 to this presentation from some of the industry experts who still contribute to this forum. And this presentation titled, Data Center Networks Are in My Way. The summary of this presentation is really that networking is not the most important asset or not the largest spend in the data center. It is about 10 to 13% of the spend, but it gets in the way of most vital optimizations in the data center. Workload placement, right? Networking gets in the way of server utilization by putting restrictions on where you can place your workloads. At that point of time, price performance in networking was very prohibitive, resulting in oversubscribed and hierarchical networks. Networking was the SUV of the data center. And if you wanted to deploy a few hundred ports of 100 gigabit Ethernet, we were talking about consuming a large rack, consuming tens of thousands of watts of power. Most of the solutions available at that point of time were proprietary, and they were vertically integrated. And the software running on these systems was based on proprietary protocols. You had millions of lines of code, most of which was not needed, but could cause meltdown in the networks. So the consensus in this forum was that networking has to move to the same model as compute. You need to move to an x86-like architecture, which is merchant silicon, which you could get from somebody like an Intel or AMD. There should not be any proprietary hardware so that you are not tied to a single vendor. You can go buy hardware from a variety of sources. The operating system has to move to a Linux-like model, and the APIs should be open. So this was kind of the blueprint. These were the requirements that were coming from this forum. And over the last 10 to 15 years, we have been relentlessly working on delivering some of these requirements. And as you can see, every 2 years, we have doubled the performance and density to a point which is innovating at faster pace than Moore's Law, to a point where we have culminated in delivering Tomahawk 5, industry's first 51 terabit chip, switch chip that's out there. And if you look at this execution, you can really tell by looking at this slide when the next generation of the silicon, the 100 terabit system, is going to be available. In this process, everybody's enjoyed 80% or 80x increase in bandwidth and almost a 10-fold improvement in energy efficiency. So a 100 gigabit Ethernet port that used to consume 10 watts of power today consumes less than 1 watt of power. But what does this execution mean for you, mean for the industry at large? It really means simplification of the systems. In this example, you can see on your screens, this is a contribution from Facebook that was done several years ago. It's a very impressive piece of hardware, but it is also very complex. You're seeing a bunch of line cards, you're seeing a bunch of fabric cards, but more importantly, in order to build this 128-port, 100 gig system, you are seeing about 12 3.2 terabit chips. They all have to work together. There is software that needs to be written in order to make this work, increasing the complexity and, frankly, introducing a lot of issues from a bug perspective that show up. Even if you go back 2 generations of our silicon, you can take what is there in this diagram and you can replace it with a 1 RU or 2 RU system with 128 ports of 100 gig, which is a drastic reduction in system power and an even more drastic reduction in system cost that has been enjoyed by the industry at large. So the bottom line, that execution translates to simplification in systems. Simplifying systems simplifies the network itself. Just as a data points, if you double the density and performance in silicon, you're essentially replacing 6 systems with a single system, just because how the network is built. So you can essentially collapse layers. You can reduce the number of optical links that exist in the network. You're reducing the hop latency. And again, you're reducing the overall system power. So this is what this execution means. It means simple systems. It means a simple network. So that was one of the first requirements from some of these cloud operators. How do we move forward from there? What was the next frontier? Right? What is the next thing in the stack? It was the operating system that is running on top of these systems. But if you simplify the systems themselves, you're essentially making it much easier to write software. And this is why we saw a slew of operating systems, open source operating systems in the market. Right? Of course, Sonic, there was FBOSS from Facebook, now Meta, there was Stratum, and several other offerings that were in the market. Now, Sonic has been an OCP project. It has moved to Linux Foundation, but it resonated with us because it very much aligned with our mission of democratizing networking. And this is why, over the last 3 years, we have worked very hard working with the community on contributions to help make this the Linux of networking, so that this operating system can be consumed not just by the hyperscalers, but by the enterprises, by the service providers, and even mid-market accounts down the road. We have been one of the largest contributors to this project, but we have been very systematic in terms of how we deliver innovations to this open source project. When we started off, we knew that we had to help our community and our partners build a very solid foundation. That's why we focused on frameworks like the Unified Management Framework, the Error Handling Framework, and to provide this foundation. The other thing we focused on was making sure that hardware is very, very quickly available on the silicon. So a process that used to take weeks and sometimes months to take out a new piece of hardware, with this contribution, the Platform Development Kit, working with our partners, we can now bring up new hardware in a matter of hours, if not less. Quality is key for open source. And this is why we have had a maniacal focus on making sure that we are automating everything and contribution of that automation back to the community. So the SPI-test framework, which is now integrated with the PTF framework, was our contribution. And of course, the community has been asking for features and protocols, and we have taken the lead on delivering a lot of those. In this forum, on different workshops, you have seen us do workshops with people like Alibaba and Meta, where we have talked about a lot of telemetry and time synchronization capabilities that are in our silicon and exposing them right up the stack. And you will see a lot of that start to show up on the Sonic project itself. Additionally, we are also trying to help move Sonic into new domains. We talked about 51 terabits and 400 gigs and 800 gigs, but there is demand for something like this in the 1 gigabit space as well. And there is a different kind of effort that is needed to make that happen that we're helping with. And lastly, one of the integral parts of Sonic has been the SCI project. And there as well, we have made very large contributions, and we continue to work with this community to enable new use cases, whether it's something like distributed chassis from Microsoft for the WAN, or whether it's enabling these 1 gig systems for the LAN itself. Additionally, now as SCI gets traction, we are working with other vendors to move Psi as an abstraction layer for other open source operating systems as well. So now that you have a foundation, you have an ecosystem of hardware vendors who are building hardware very fast, you have got an operating system that works on top. The next frontier or the next destination was really to make sure that the application stack at the above layer could really benefit from all of this. And this is why one of the key contributions that we are very proud of is the Unified Management Framework. And this is a set of open APIs and interfaces like GNMI, REST, and even CLI to hook onto monitoring tools, automation tools, controllers up the stack. So Sonic now can integrate with things like DevOps tools like Chef and Puppet and Ansible. There are a lot of companies out here, very good partners, who have integrated their controllers, companies like Apstra and Open Daylight, with AT&T and Pantheon and Beyond Edge, and we will hear something from Shasta Cloud. There are others who are doing the work like Avis and Hedgehog that are coming into this picture. And then last but not least, the monitoring tools. We wanted to make sure that all options are open, whether you are trying to monitor on your own, whether you are using a third-party tool, or whether you are using open source like Grafana or other tools, you're able to do that. And that is what was enabled with this. And this is why, all of this work, working with our partners, has now created a very healthy ecosystem at all layers of the stack. And something that was available just to the hyperscalers can now be enjoyed by the broader market, whether you're a service provider, whether you're an enterprise, or a mid-market account. Now, OCP has been a key forum for us, right? When we talk about open standards, open APIs, and this is why we have been very involved, whether it's submitting system designs, architectures, or specifications. Last October, we announced Tomahawk 5, which was the industry's first 51 terabit switching silicon, consuming the lowest amount of power, but also providing the longest reach, right? We can give up to 4 meter at 100 gig for DAC cables. This is double the specification, the IEEE specification that's out there. Today, you heard about Jericho 3 AI. It's a revolutionary architecture for AI networking. And as we talked about, a key metric in AI networking is reducing the job completion time. And with innovations like perfect load balancing, congestion-free operation, zero-impact failover, we can achieve that with this Jericho 3 AI fabric, and we can do that at scale for up to clusters of 32,000 GPUs. Now, something that started in the hyperscaler environment has also now been enjoyed by the service provider. AT&T has been key in terms of submitting with us some of these designs for the disaggregated chassis. Over here, think of a chassis which is a scale-up systems. You break it up into pizza boxes, where you have line cards becoming pizza boxes and fabrics becoming pizza boxes to give very, very large scalable networks that can be deployed in core or edge of service provider networks, complementing the work that again started with AT&T on the cell-site router. And tomorrow, you will see us talk about this open LAN architecture and unveil an architecture, which again, like I mentioned, moving down the stack, kind of like how do you enable an ecosystem of 1 gigabit, multi-gigabit PoE switches, which are running Sonic, but also have cloud management, which is based on open APIs. And now we also have customers who are now coming to this forum that you can actually reach out to and talk to. They're very happy to talk to you, who are now leveraging some of this open networking architecture. Line is probably the largest messaging app in Japan, And they moved to this open networking architecture across the data centers, and they talked about it in the last OCP forum. AT&T is here, and they're going to be talking about how they delivered a managed service using this disaggregation open networking technology. And it's not just talking about hardware or the operating system, but how do you also integrate it with the controller, right, at the application layer of the network. Very excited about the presentation that's going to be happening with Deutsche Telekom as they roll out 5G in their environments based on a Kubernetes infrastructure. How are they using open networking in Sonic to connect all of this network together? And lastly, even universities like EPFL, who have come to this forum and talked about how they transformed a hierarchical architecture that they had to a modern architecture based on open networking in Sonic. So this has been a long but very exciting journey. We are very thankful to this OCP forum, to our customers, to our partners who have been on this journey with us. But as we stand here today in 2023 in this OCP summit, data center networks are still in the way. We have done a lot of work and a lot of optimizations, but data center networks are in the way of most vital optimizations for the emerging workloads, whether it's HPC, whether it's AI or ML workloads. And we heard that when you're doing AI processing, networking is consuming about 50% of the time. We are very excited about some of the announcements to solve some of those problems today with the Jericho 3 AI Fabric. But we look forward to working with this community, this forum, with our partners over the next 2 to 3 years to really solve this problem. Whether it's in improving performance, lowering the latency, optimizing the power, improving sustainability, or continuing this work on open software. Thank you very much for your time. Thanks.